Okay, so we're going to go through a whirlwind tour of remote sensing, and this is so overly simplified, um, but and it's also pretty powerful. I mean, you can take an entire year of remote sensing, but we're going to go through basically displaying Landsat imagery and then doing a very easy classification so that you can uh, uh, identify changes over time. Sorry, I was reading the notes. Okay, so I have a geodatabase that's labeled with this year. There is a feature data set that has a region of interest that I have added to my table of contents and made hollow. I have some evaluation points, and then there are several Landsat scenes. There is one that is a composite scene that has bands 1, 2, 3, 4, 5, and actually this is band 7. So I'm going to go ahead and change that so I can compare apples and apples later. When you create a composite band or composite scene, ArcMap just labels them in order, and we skipped band 6, and you'll know about that in a minute. So this, and that's 1987. I also have 1, 2, 3, 4, 5, 6, 7 individual single band images from 2016. So I'm going to just add these in order. And single bands come in a grayscale. Images, like the image we did or a PNG, comes in RBG colors, but when it's single band, it comes in like that. So I've got my my bands 1 through 7. Let me double check. 1, 2, 3, 4, 5, 6, and 7. 6 is a thermal band, and so it often has a different spatial resolution. In this case, it has the same spatial resolution as the other ones. The values that you're seeing is the reflectance or the digital number given as a color value from 0 to 255. And so if I'm looking at the spectral band 1, I'm going to go ahead and close these up, which is the blue band, I'm getting reflectance or digital numbers from 46 up to 255. And so the more reflected areas, the higher reflectance is the lighter color. And you can see that this forested area here is a darker color. So part of this lab is to evaluate the different bands and kind of see what information they can provide you about the landscape. And I'm going to have you go into the XY tool here, and remember ArcMap enters things in non-conventional. Oh, it's not going to let me copy that. So they list longitude first and then latitude. And I'm going to zoom to that, and I'm just going to put a point on that. And I'm going to zoom into that pixel. So I'm going to zoom way in here. Okay, so I'm looking at that pixel here, this one right there. And if I use the Identify tool, I can click on that pixel, choose band 1, click again because now that I have to do that, and it tells me that the value is 59. So the color value given for the reflectance of this particular band is 59. So the blue light spectral value is 59. I can go into the green, I think is the next one. Let me go. Yeah, green is number 2. Click again. So there's less green. So this value is 21. I can go into the red, 14, so even less red reflectance, and I can go into the near infrared, even less. So far, looking at all of these reflectance by individual bands, so I can look at that as well. You might want to turn on the effects tool, and the effects tool allows me to so I'm looking at band 1 and I want to see the aerial imagery below that. I can use the effects tool to kind of scroll up or scroll over and kind of see what's below that. So that's a really nice little tool. Oh, I'm looking at water. Okay, so I'm checking that out that way. So I want you to evaluate the band combinations for that spot and tell me what the digital number is, which is the pixel value. And then you're going to, after you've looked at these, you need to create a composite view. So I'm going to go ahead and zoom to this layer. And I'm going to remove layer 6 because I want to make, oh, I missed number 5. Where did that go? There we go. 1, 2, 3, 4. I'm going to move it down here. One, 2, 3, 4, 5, 7. Good. So I want to create a subset that is just this region of interest here. So I'm going to extract each of these by mask, and then can I get rid of this thing? Maybe not. Yeah, I'm going to extract each of these scenes by a mask, and the mask is going to be my region of interest, and then I'm going to create a composite of all of these scenes so that I can look at the different bands. So the composite, let me show you one that's already been done for you, or not. I'm going to close that. I'm going to go ahead over here and I'm going to add the multispectral image from 1987. You see how that came in as a colored scene. I'm going to zoom to that layer. And this fits my region of interest. So the multispectral bands allow me to put different values or different bandwidths through the different color channels. So let's say I want to look at false color. So right now what we're looking at is true color. This is the way most images come in. But I want the near infrared to show up as red. I'm going to put my red through the green color channel and my green through the blue color channel. And then what I get is called a false color image. And with these different spectral bands, I can get many different color combinations. And if you would refer to the handouts, there are different values that are used to identify specific features. So for example, oh, look at that. See, there is something very cool. And I don't know why those fields show up as brown. They're hard to distinguish. Oh, got to turn that on, blah. Huh. But they're different time frames too, so it's kind of hard to... But look how well the water shows up using that color combination. Interesting. Okay, so first thing then you have to do an extract by mask. And so you're going to make sure that your spatial analyst extensions are on. You're going to go into the toolbox and you're going to go to, where am I going? Spatial analyst, extraction, and extract by mask. So then I'm going to put in band 1. And I'm going to put in the region of interest, and then I'm going to have this go into my geodatabase. And so I'm going to call this one band 1, band 1 EUG 2016. Okay. All right, so I'm going to make sure that fits my, right, so there's my first band. So now I'm going to remove this. So I'm going to do that with the other 7 bands. So I now have subsets of all 7 bands. You can see them in my table of contents. So now I'm going to create a composite. So I'm going to go to Data Management and raster processing and composite bands. So I'm going to select, I think you can select all of them at once, so let's just try that. What the heck. 3, 4, 5. And I'm not sure that the order matters, but I'm going to make sure mine are in order 1, 2, 3, 4, 5, and 7. I'm going to put this in my geodatabase now as Eugene multi 2016. Okay, so I'm going to have that. Okay, so there's my multispectral image, so I can remove these singles. And it's coming in with, let's go to properties here. So I want my red through the red band, my blue through the blue group band, or my green RBG, blue, 3, 2, 1, there we go, that should work. And so now I'm back to kind of true color. And this is percent clip. Okay, so that looks good. So that is the true color imagery for my spectral bands of my new subset. So what I want you to do now is to be able to evaluate the different features as they show up in or the DN numbers from these different values. So that made no sense at all. So I'm going to go in here to point number 1. And now if I click on the Identify tool and I choose to identify information from my multispectral image, it's going to give me the comparative reflectance. So there's blue is 59, green is 21, and red is 14. So that gives me my reflectance value here. And so what I want you to do is to look at all of the 6 points and get a sense of how these different values reflect. This is in true color. You can also look at this now in false color, which is your near infrared. 432 band combination. It shouldn't change your reflectance values. So here's cloudy water here, and again a little more near infrared, but look at the difference if I look at a really brightly reflective pixel that's showing vigorous growth here. So you're going to evaluate those features, and then you're going to make a map showing this one is true color, and then another data frame with false color. and then you'll pick two other color combinations and discuss those. So in your layout, you would have, oh, you're not in true color at all. There you go. So there we go. So you're going to be able to talk about the different uses for different color combinations and what the functions would be for those. And that would be the first PDF that you'll turn in.